This is going to be a quick video explaining how to convert between the three forms of expressing imaginary numbers. There are three forms to express these numbers: Cartesian, polar, and Euler form. The Cartesian form naturally expresses a complex number in terms of an x and y coordinate, given that the y-axis expresses the imaginary component and the x-axis expresses the real component, so it can be expressed as a coordinate on the Cartesian plane. Polar form utilizes a similar concept to the unit circle, where cis represents cosine plus I sine. This can be imagined as a vector originating at the origin and pointing out into some direction at the coordinate that would be expressed in the Cartesian form. Euler form is very similar to polar form and is simply another way to express it. Now, to convert Cartesian form, given one is provided an x plus iy, the conversion requires two variables to be converted into two different variables. In this case, the r is known as the modulus, which is essentially the length of the vector originating at the origin and pointing to the coordinate point. So if we use Pythagoras, then we know the x value of the point squared plus the y value of the point squared. The square root of that will be the distance from the origin to this point. The angle is then, in similar fashion to how the unit circle operates, expressed from pointing directly rightward on the x-axis, and that can be found using the inverse tan function of y over x. This is pretty self-explanatory, pretty standard. Once you have these two variables, it can be expressed completely as that value r cis of theta. If you're converting between polar and Euler form, you literally don't need to do anything. You can completely put the same modulus multiplied to Euler's constant to the power of I multiplied by the argument. And if you were converting from Cartesian form to Euler form, you perform the exact same operations to find r and theta and do the exact same. Let's be honest, you shouldn't really convert from Euler form to Cartesian form. You can very easily, just by inspection, convert back to polar form from Euler form, and from there it's easier to convert to Cartesian form. What you can do is, you can remember the polar form is r of cosine theta plus I sine theta. Now, I don't know about you, but it looks pretty familiar. If I were to get r cosine of theta and I were to get r sine of theta, could I not replace that for x and y? Could I not say that x here is the same as r cosine theta, and then y here is r of sine theta? I could, because this is actually literally just in Cartesian form, but we've expressed it in a, I guess, simplified manner. So in order to convert polar form back into Cartesian form, you will expand it in this form and simply solve for r cosine of theta and r sine of theta, and that's your x and y.